which now will start at a small circle, go to a larger circle in the middle, and now it's a polygon at the very end here. But that's not quite what I want. It's just a demo. Now, an entirely different method, instead of using multiple profiles, is to use what's called a scaling rail. Now, a scaling rail is an additional curve that I draw along the rail, and it will be used to stretch the profile to match up to this curve, and you can get a much more customized type of shape using this method. So now if I take my circle, which I shouldn't have deleted, but there you go, it's back again, and sweep it along this shape as the rail, now I can use this pick scaling rail option, pick this as a scaling rail, and you'll see how this deforms to stretch out to meet the shape there, to meet the scaling rail. And let's take a look at that. That's much more the kind of customized shape that I was thinking of, and at every point along it, it's matching this scaling rail profile. It stretches, and it stretches from the center to meet those. Now you can see that it's stretching only in one direction, that it stayed the original width in here, and that's what this maintain height option does. I'm going to go here and uncheck that because I kind of want it to be scaled in all directions instead of just that one direction. And that's sort of the shape I was thinking about right there. At this point, I'll hit done, and you can mess around with this scaling rail too before deleting it. So for instance, if I stretch it out this way, you'll see the sweep update. And you can play with it and tweak it, fine-tune it. Let's just see what that does. It'll be kind of rather lumpy now. But actually I'm going to undo that because I kind of like my original one. Now I'll just delete all of these. So this scaling rail is a rather powerful way to create a custom tubular shape. With only these three curves, a circle, the central rail path, and the scaling rail, three curves created this quite custom leg shape. So now I will select these two and use construct Boolean union to fuse them together into one object, one solid. Then I will select the edge where they meet, and to select an edge you select the entire object first, and then you move over and click a second time, and the second time you click on a solid, the selection will drill in and move to edges or faces. So that's how I selected it. By clicking a second time I selected this edge. And now I'll perform a fillet, construct fillet, and I'll just pick 2 points to define the distance. Maybe I'll go a little bit larger than that. I'm looking up here to see the distance that I'm getting. And maybe even a little bigger. Alright, right click to accept that. Now I'll take this solid and I'll say transform array circular around the origin point, and I'll make 6 copies. Now I think I'll bring this down slightly. Alright, now I'll select all of these and say construct Boolean union. Now these have all been fused together into one solid. This is in one single solid, this whole object now. And now I will select these edges And you, after you select one edge, then you can do a window select, and it will target um, edges. So it sort of primes the pump in a certain way. If you select a face, so for instance, if I went here and select this face, now window select will select other faces. And if I select an edge, then another window select will select edges. And sometimes it helps to sort of line things up so that you can do a window select a little easier. So for instance, right here, I'm lining this up so that these are all nice and easy to capture with one single window. And now I've selected all those edges. And now I'll fill it again. And let's see, that might be a little bit large for that area because they'll run into each other here. I'll just pick two different points to interrupt that and calculate a slightly smaller fillet. But I can go a little bigger than that. I'll try 1. Just type in 1. And it looks like I can even go a little bit more. Let's try 1.2. Alright, well, any much more bigger and they're going to start to run into each other. So that's it. Right click to finish fillet. And this is my strange six-legged pod. It's just a demo of a kind of form and shape that you can build, and I built this part was a very symmetrical pod at the top, so it was a good candidate for using one profile curve with revolve to build it. This one was a little more squished down, and I used rail revolve, which is a variant of revolve that takes a path curve that squishes the revolve to a profile, to an additional profile. That's what was used for this foot. And then the leg, a one rail sweep that had a scaling rail to customize the shape, and then Boolean union and fillets to join everything together and round off the sharp edges. And that's how you get a six-legged pod.